this chapter, we will be looking at topics related to measurement. In this lesson, we will be reviewing the metric system.
All right, so in this lesson we're going to be talking about measurement, as we will in the whole chapter here. We're going to be talking specifically about the metric system for this particular lesson here and introducing it. Now, this really shouldn't be an introduction. This should just be review. I'm assuming that most people here at this point have seen the metric system, have talked about the metric system in other classes here. We're just trying to review it real quick here. So remember, when we're talking about measurement here, we're just trying to find the size of an object. Now, that's specifically what we're doing in this course. We're going to spend most of our time focused on length measurements, not necessarily volume and whatnot. Although volume and surface area will be part of the process later on here. Our focus specifically is on measuring lengths. And we're going to typically use the ruler, measuring tape, yardstick, meter stick, and then a trundle wheel, which can be kind of fun to play with. So there are two types of systems used in the world. There's the metric system and the imperial system. Okay, we're going to start by looking at the metric system here. So the metric system is also known as the SI system. It stands for the System International, the unit. Okay, whatever. I know I'm mispronouncing that. That's okay. But it was developed in France a couple hundred years ago, just to standardize measurement around the world. Now, most of the world uses the metric system. It's a beautiful system, and it's based on multiples of 10, right? At least the conversions are, which makes it so incredibly useful. Now, before we get into that part, one of the things we want to introduce in this course is this concept of a referent. Okay. Now, unfortunately, it's more difficult to do that over a video medium like this, at least for what I'm trying to accomplish with these videos here. Normally, this would be something that we would talk about more in class, and we would do examples of this and whatnot here. But what you got to understand by a referent is when you're interacting with objects in the world and whatnot, you often make estimates about the dimensions of certain objects and whatnot. Sometimes you're being asked to make estimates about lengths and whatnot. A referent is a tool that you use. It's something that you're familiar with, an object that you're familiar with, that you have a pretty clear idea of what its length is. Okay? So, for example, the thickness of a dime is a really good referent for 1 millimeter. Okay, you're comfortable with a dime. You've used money. You know you have a clear idea of how thick that is. Well, that is a good approximation to 1 millimeter. Okay, the width of your pinky finger. Okay, that is a fairly good reference on average for 1 centimeter. Now I have to say on average here because obviously you realize that people are different sizes, and so it's not perfect because, you know, the larger you are, the bigger that's going to be, the bigger the approximation is. Okay, and the smaller you are, then the smaller that's going to be as an approximation for 1 centimeter. But on average, that's actually pretty accurate. Okay, the hand width, okay, you put your hand down here, across here, that's actually on average, once again, fairly close to 1 decimeter. Okay? Again, not perfect because it changes from person to person, but on average, yeah, that's probably a good reference for that length of unit. Sorry, unit of length there. Wow, that was odd. The height of a standard doorway is about 1 meter, and the height of a standard doorknob is about 1 meter. The height of a standard doorway is about 2 meters. Yeah, that's pretty good. That's actually really quite accurate. And then the distance walked in about 20 minutes or about 8 city blocks is about 1 kilometer. And again, that's for most people, that's going to be fairly accurate. Okay, so these are just some ideas, some things that you need to be aware of as you move through this course, because you will be tested on reference. But really what we're testing here is how closely or how much you understand these units of measurements in terms of their dimensions. So we're going to ask you questions about objects that you're fairly familiar with, and we want to know that you understand, roughly speaking, how large they are. okay, in terms of the metric system. Now, let's get into what makes the metric system so awesome. Okay, now right here, when we talk about metric units of length, okay, here are our symbols for them right here. We start off with the meter. Okay, now the meter, like we said, if you want to have an idea of what it is, it's about the height of a standard doorknob. Okay, if you don't already have a clear vision of that. But what they've done here is there is a stick with a notch in it, and that gives us the length of a meter, and that is stored in France in a museum. Okay, now we have now developed since then a more precise means of defining a meter, but for a long time that was the standard meter. Now what we do with that then is we break it up into tenths, or then we multiply it by 10 here. So this is what creates the metric system. So the farther we go this way, the larger the units get. Okay, we're getting larger here. When we go this way, we're talking about smaller units. Okay, so this is the decameter. Okay, the decameter is 10 meters. Okay, the hectometer is going to be 10 decameters. The kilometer is going to be 10 hectometers. Now, on this side, though, the decimeter is 1/10 of a meter. The centimeter is 1/10 of a decimeter. And the millimeter is 1/10 of a centimeter. So we're always moving out from the meter by either by multiples of 10, if you want to think of it this way. Here we're multiplying by multiples. This is multiples of 10. Here we're dividing by 10. Okay, and then here's a chart to help us illustrate the way this all works here. Again, starting at the meters. Okay, so 10 decameters. Sorry, 1 decameter is 10 meters. Okay, 1 hectometer is 100 meters, 1 kilometer is 1,000 meters. And in fact, well, yeah. You want to get used to the idea of what the abbreviation means, what those prefixes are referring to. Because really, that's what gets used over and over again. The fact that we're talking about meters and whatnot, that's great. But you should be able to convert these over, for example, kiloliter, hectoliter, decaliter, deciliter, centiliter, milliliter, okay? And understand how all of that works with respect to that unit of volume, the liter. Because they're all going to be consistent with this system right here. So another thing that you want to notice here is that, and this comes down here, that when you're converting between units here, remember that you're going to move, okay, when you move the decimal to the right here, when you go from a big unit to a small unit, okay, so if you're going from kilometers to meters, when you go from big unit to small unit, the number should get larger, okay? The number should get larger. That should make sense here, because if you've got 1 kilometer, well, that's 1,000 meters. 1 big unit is the same as a whole bunch of smaller units. Just like if you're going to move, when you move the decimal left, when you're converting from a small unit to a large unit, okay, from small unit to large unit, remember that as soon as the unit gets larger, the number gets smaller. And that's what you're seeing here. Which makes a lot of sense when which may or may not make a lot of sense when you just describe it like that. What we really need to do is start working through some examples, and hopefully you'll get a much clearer sense of how that works if you don't already. All right, so let's just get into making some conversions here. So we're going to convert 29.7 kilometers into decimeters. Okay, kilometers to decimeters. Now let's just take a quick look up here. From kilometers to decimeters, that's 1, 2, 3, 4. That's a jump of 4 units. Okay, so the decimal's going to move 4 places. A decimeter is much smaller than a kilometer. Okay, so when the units get smaller, the number should get larger. So 29.7, I'm going to move this 4 decimal places. 1, 2, 3, 4. So that'll be 0, 0, 0. So we're going to get 297 1,000 decimeters. Okay? And that actually makes perfect sense. Because think of it like this. The way most people think about it, because most of the time we don't work with decimeters. Most of the time we're working with meters and whatnot. A kilometer is 1,000 meters. So 29.7 kilometers is 29,700 meters. And then a meter is now 10 decimeters. So you add just another there. That might be, for some of you, even an easier way of thinking about it. Okay, let's convert 134 millimeters to hectometers. Okay, well, let's go back up to here. So a millimeter to a hectometer, that's a big jump here. That's 1, 2, 3, 4, 5 jumps along this scale. Okay, so that's 134. Remember, we're going from small unit to large unit. So what that means is that the number has to be getting smaller. So 1, 2, 3, 4, 5. There's my decimal now. So it's 0.00134 hectometers. Okay. 1,400 decameters. Convert that to centimeters. Okay. So there's 1,400 decameters. Well, let's go back up. Decameter. Okay. Well, to get a centimeter, that's 1, 2, 3. Okay, they differ by 3, so we're going to move the decimal place 3 times. It's right here. From large unit to small unit, the number should get larger, so I got to move it to the right. 1, 2, 3. So what have we got here? That's 1,400,000 centimeters. Okay? 7,852 meters to kilometers. Well, this one should be a little bit easier, because most of us will know how this works here. To go from meters to kilometers, well, there's 1,000 meters in a kilometer. Remember, we're going from a small unit to a large unit. So when the unit gets larger, the number gets smaller. So I'm going to move the decimal to the left. 1, 2, 3. So that is 7.852 kilometers. Okay. 5.21 meters. We're going to convert that to millimeters. Okay, so 5.21 meters to millimeters. Well, let's go up here. This one might not be as obvious, but it's 3. Okay, there's a jump of 3 there. So we're going from large unit to small unit. So the number has to get larger, and because there was a skip of three units there, it'll be 1, 2, 3. Throw a 0 in there, so 5,210 millimeters. Centimeters to millimeters. Okay, well, this is a more common one. So here we go, 2.7 centimeters. I'm going from a large unit to small unit. So when the unit gets smaller, the number gets larger. So 2.7, there's just a jump of 1 in terms of the units here, so a multiple of 10 here. So it's going to move over just 1. So 2.7 centimeters is 27 millimeters. All right. Whoa, 0.23456 kilometers is how many centimeters? Okay. Let's take a look at that chart again. That's 1, 2, 3, 4, 5. Okay, that's 5 steps along that chart here. So I'm going to move the decimal 5 places here. And because I'm going from large unit to small unit, the number should get larger. So that means moving the decimal to the right. So it's 1, 2, 3, 4, 5. And it was probably easier to do it here. So that's going to be, what did I say here? 23,456.7 centimeters. Next, we're going from decimeter to millimeter. Okay, let's take a look here. Decimeter to millimeter. Oh, that's just a jump of 2. Okay, decimeter to millimeter. But again, the unit is getting smaller. So when the unit gets smaller, the number gets larger. And that means moving the decimal to the left. So that is going to be, what do we got here? 23,465.32 millimeters. Okay, millimeters to meters. Hopefully we're starting to get more and more comfortable that you're not having to keep going back to that. But to go from millimeters to meters, that's 5 steps along that scale. We're going from small unit to large unit. So when the units get larger, the number gets smaller. So that's again, that was 3 steps along that scale there. So I'm going to move this one back 3. 1, 2, 3. I'm going to introduce a new 0 there. So 0.050505 meters. Okay. Centimeters to decameters. Okay, well, to go from centimeters to meters is a jump of 2. And then to go to the decameter is another jump. So that's basically 3 steps along that scale. I'm going from small unit to large unit. So the number should get smaller. So the decimal's right here, so I'm going to move it 1, 2, 3. So 0.013 decameters. To go from hectometers to decimeters, well, a hectometer to a meter, that's a skip of 2 steps along that scale, and then the decimeter introduces another step, so that's 3. We're going from large unit to small unit, so the number should get larger. 1, 2, 3, plug in the zeros, so 4,700 decimeters. And now finally, from kilometers to hectometers, that's just a skip of 1. Okay, kilometers and hectometers are right next to each other in that chart. So, and we're going from a large unit to a small unit. So the number's got to get larger, and we're just going to move it 1 over. So 3.15 hectometers in 0.315 kilometers. All right, now we're going to look at converting square units, converting area units here. Now, this can be a little bit more confusing, so I want to try to simplify this as much as I can. Let's just take a quick look here. Let's say that I've got a square that is roughly 1 centimeter by 1 centimeter, okay? 1 centimeter, 1 centimeter. So this one here is 1 centimeter square, okay? Now, how many millimeters is it along this side? Well, that's 10 millimeters. How many millimeters is it along this side? Well, that's 10 millimeters. So if it's 10 millimeters this way and 10 millimeters this way, how many square millimeters is this area? Oh, well, it's 100 millimeters squared. Now notice, to go from 1 to 100, I moved the decimal place over twice. Okay? See, here's the common mistake that gets made here. People will think that, oh, because I go from centimeter to millimeter, there's only going to be 10 millimeters squared in a centimeter squared. That's not true. Okay, because this is a square unit here, it's 10 this way, 10 this way, for a product of 100. Now, if that's confusing at first here, it can be made simple, because really, in order to convert these units, all you have to do is you're going to, for example, let's just jump right into this and I'll show you here. If we're going to convert centimeters to meters, I know, okay, that there are 2 steps along that scale that we were working with just previously here to go from centimeters to meters. And I'm going from small unit to large unit, meaning that my number is going to get smaller. So the decimal is going to move to the left here. But now instead of moving 2, it moves 2 spaces horizontally, 2 spaces for the, 2 spaces for the horizontal component, 2 spaces for the vertical component. That's 4. So it'll be 1, 2, 3, 4. There's where my decimal goes. And so this is going to be 0.0003 meters squared. So for every step that I see as a difference along that scale from centimeters to meters, because I'm talking about square units, I'm going to double that number of steps here. So let's take a look. 2.7 centimeters squared to millimeters squared. Well, okay, there's a single step to go from centimeters to millimeters. So I would, if it was just centimeters to millimeters, I would move the decimal once. But because they're squared, for every step there, I'm going to do it twice. So now I'm going from large unit to small unit. The number should get larger, so the decimal is going to move to the right 2 times. So then there were 270 square millimeters in 2.7 square centimeters. Okay, centimeters to meters. Okay, once again, if I'm going from centimeters to meters, okay, along that scale, if they weren't square units, it would be just a movement of two spaces for the decimal. But because it's squared, I'm going to double that. So this is now going to be 4 places. So 42,000. Here's the decimal. I'm going from small unit to large unit. So the number is going to get smaller. So I'm going to move this 1, 2, 3, 4 to get 4.2 meters squared. And then now finally in this one here, I've got millimeters squared to meters squared. To go from millimeter to meter, that's a move of 3 along that scale. So because these are square units here, what's going to happen is I'm going to have to move that 6. I'm going from small unit to large unit, so the number should get smaller. So I'm going to move the decimal 1, 2, 3, 4, 5, 6 to the left to get 5.2 meters. Okay, I hope that makes sense. All right, so in these next couple of examples here, and I'm just going to do kind of one at a time here, but when we start to determine area, you really do need to pay close attention to the units now in this chapter, because we're going to start to move between types of units here. So just take a look at this first example. Determine the area of a rectangle that is 1.5 meters by 2.6 meters. Okay, so 1.5 meters by 2.6 meters. Now, there's a couple of different ways, there are a couple of different ways that you could do this. We could, for instance, say that, okay, our area is going to equal length times width, okay? And so now we've got 1.5 meters, so I'll just write this out here, 1.5 meters times 2.6 meters. Okay, I'm just going to do this really quickly on my calculator, because I don't want to write the wrong thing here. So this is going to be 3.9 meters squared. Oh, but they didn't ask me for it in meters squared. They wanted it in centimeters squared. So then what I might do here is take 3.9 meters squared is going to equal, okay. To go from meters to centimeters, I'm going to move the decimal 4 times. Okay, normally for meters to centimeters, I just move it twice, but because it's squared, I'm going to move it 4 times. And to go from large unit to small, the number's got to get larger. So I'm going to move that decimal over 4 times. So 3.9 is going to become 39000, 1, 2, 3, 4. So this will become 39,000 centimeters squared. That is one way of doing this. Or you could convert early, and instead of moving the decimal for these square units, I could simply move them on the linear units here. Okay? So, for example, if this is 1.5 meter, okay, convert 1.5 meters to centimeters, that's 150 centimeters. Just move the decimal 2 to the right. 2.6 meters is the same as 260 centimeters. And then your area will simply be 150 centimeters by 260 centimeters. And again, we get that 39,000 centimeters squared. This next question is actually very, very similar to the one that we just did. Determine the area of a rectangle that's 40 millimeters by 15 millimeters in meters squared. And again, we can do this a couple of different ways. Let's say that this is, here's our 40 millimeters, here's our 15 millimeters. So the very first thing that we could do here is make this length times width, and then just 15 times 40, okay, is going to be 600 millimeters squared. And then we'll convert 600 millimeters squared to meters. Meters squared. Now, to go from, that should be millimeters squared. To go from millimeter to meter, just if it was just linear units, that's a movement of 3. But because they're being squared, we're going to move 6. And because we're going from small unit to large unit, that number is going to get smaller. So I'm going to move that decimal 1, 2, 3, 4, 5, 6. And so this will be 0.0006 meters squared. Or we could convert earlier, and 15 millimeters, if I convert this into a meter here, I'm just going to move that decimal 3 to the left, so 0.015 meters. And 40 millimeters is going to be the same as move that decimal 3 to the left, 0.04 meters. And so now my area is going to be 0.015 meters times 0.4 meters. Whoops, I'm right off the screen there. And then again, that'll equal 0.0006 meters squared.
Now we will talk for a few minutes about scale factors.
All right, well, one of the applications of this that you're going to have to get comfortable with is scale factors. Okay, you're going to see this come up. Well, actually, you're going to see this come up a lot, kind of all over the place. But it is something that's going to be specifically tested here. We're talking obviously about maps and blueprints when we talk about scale factors. And what we're doing here is we're just setting up a little proportion. Okay, we're setting up a little ratio here. And the way we set this thing up here is we always use scale to the actual. Okay, so this is like your, if you want to think of it like this is your drawing to the actual object. So if you've got a 1 to 3 scale, that means the drawing is like 1 unit for every, or I should say it like this, maybe that makes more sense. For every 1 unit on the scale, that represents 3 of the same unit in the actual. So this would be a reduction. Okay, the drawing is 1/3 the size of the original. However, if it's 3 to 1, then every 1 unit of the actual is represented by 3 of those same units on the scale. And so this would be an enlargement. Okay, so it's gotten bigger here. When you're dealing with scale, the units, and when we're talking about a scale factor, the units should be the same. Now, that's a very, very mathematical approach to that. Because you're going to find in a lot of cases when you talk about maps and you see diagrams in textbooks and whatnot, they won't be the same. But if it's not going to be the same, then what they have to do is they have to give you exactly what those units are that they're comparing here so that you can make an intelligent comparison. Okay? But when you're given a scale like this without any units to it, we have to assume that it's the same unit on both sides. And then if that's the case, it doesn't really matter what the units are. Conversions are quite straightforward. Let's take a look at some examples. All right, so in this question we read here that the scale on a map shows 1 centimeter equals 5 kilometers. Okay, and that's how you're normally going to see this. You're not normally going to see them when we apply scale factors being really, really strict about the mathematical definition where the units are the same on both. Normally they're going to play with a little bit. So really what they're doing here is it's not so much a scale factor as what it is a proportion that they're setting up. So in this question, if the distance between A and B is 7.1 centimeters, how many kilometers apart are A and B? So we're going to set up a proportion here. So 1 centimeter over 5 kilometers is going to equal 7.1 centimeters over X. Okay, I don't know. I don't know what that is. Now I'm going to be really clear on this. Once I know what a value is, okay, I'm going to associate the units with it. But if I don't know what it is, I don't know what it is. Now to solve this, I'm going to cross multiply. So 1 times X is X, and I've got centimeters there. 7.1 times 5 is going to be 35.5, but I've got this centimeters times kilometers there. Something weird going on with the units, but notice that I can cancel the units. Now it's interesting, and you should have seen this in like a science class, that you can do that sort of math with the units, and it works out just fine here. So this tells me that X is equal to 35.5 kilometers. Therefore, A and B, okay, are 35.5 kilometers apart. Whoops. That's what they're looking for. All right, so a similar sort of question here. The height of the CN Tower in Toronto is 533.3 meters. The scale used to draw the tower on a tourist poster was 1 centimeter to 75 meters. Okay, once again, we're playing with this kind of definition of scale factor here. This just is really just as a proportion they're setting up here. We want to know the height of the tower on the poster and round our answer to the nearest tenth. So on the poster, that's the drawing. And so this ratio is drawing to actual. So drawing to actual. In this case, we know that it's 533.3 meters. So once again, I'm going to cross multiply. So 1 times 533.3 is going to be 533.3 centimeters times meters. And then 75 times x, well, it's just going to be 75x meters. Now, I'm going to isolate the x here by dividing by 75, and at the same time I'm going to cancel out those meters there. And 533.3 divided by 75 is going to be 7.1 centimeters to the nearest tenth. So the drawing, sorry, did I say 71.1? I'm just 7.1. Is, sorry, now my sentence doesn't make sense because I second guessed what I just said. The drawing is 7.1 centimeters tall.